Amin Hammad from Concordia University. The title of my paper is Discrete Image Simulation of Multipurpose Utility Tunnels Construction using Microtunneling. Utility networks are installed above and below the ground, and there are different reports which state that underground utilities in developed areas have reached or are nearing the end of their service lives, which needs many repair and replacement projects. And as we can see in the figure, in the picture, it could cause disruption to the surface. Therefore, tunneling projects are designed to enable the execution of underground work with minimal disruption to surface and traffic, as we can see in the second picture. Multipurpose utility tunnels are defined as underground utilitors containing one or more utility systems, permitting the installation, maintenance, and removal of the systems without making a street cuts or excavation. As an example, in this figure, we can see different components of MUT, such as gas and water pipes, telecommunication and electricity cables, as well as MUT ancillary facilities like security cameras or hoisting system. MUTs are more expensive than conventional methods, but they could be more practical in dense areas due to social cost savings. And different factors could affect the feasibility of MUT projects, including utility specification, MUT location, and construction method, among which the construction method is one of the most important factors that should be carefully assessed to make MUTs an affordable and efficient alternative. MUT construction methods can be divided in two main types, which are cut and cover methods and trenchless methods. Trenchless methods are more expensive, but avoiding excavation of streets and roads, as well as low social costs, can make these methods more practical, especially in dense areas. Also, it should be mentioned that using cut and cover method is almost impossible or more expensive in dense areas, deep MUT projects, or in some special geological conditions like hard rocks. In cut and cover method, the tunnels are constructed in the following order. A trench is created, the tunnel structure is implemented, and the trench is filled up. And after that, the pavement will be restored. The support of the vertical sides is one of the most important considerations in this method, which can be done using diaphragm walls, second pile walls, soldier piles and lagging, and steel sheet pile walls. As an alternative to cut and cover method, in microtunneling method, as we can see in this figure, the jacking pipes are jacked from a starting shaft up to a target shaft. And at the same time, a remote control microtunneling machine carries out the full face excavation of the working face. Depending on the way of conveying the spoil, there are three types of microtunneling boring machines, including auger spoil removal, hydraulic spoil removal, or pneumatic spoil removal. Some important parameters like type of the ground, groundwater level, and existence of boulders should be considered for selecting the type of MTBM. Like other fields, simulation can be used in construction for planning and resource allocation, risk analysis, site planning, and productivity measurements. DES method is a common type of simulation in which we should break down the activities into different tasks, and each of these task duration is presented by a probabilistic distribution. The main objectives of this paper are analyzing the duration of MUT construction projects using DES method focusing on microtunneling, comparing the durations of microtunneling and cut and cover methods, and evaluating the impact of soil conditions and tunnel diameter on the duration of the project. To meet the objectives that I mentioned, the proposed methodology developed in 6 steps: analyzing the location of the MUT, selecting the construction method, defining the sequence and relationships between the activities, defining the probabilistic distribution of each activity, calculating the duration of the project, and comparing the durations of the construction method. And here I need mention that in this paper, only 4 last steps have been done. MUT construction method using microtunneling can be divided in 3 main steps, which are shaft construction, tunnel construction, and placing the utilities inside the tunnel. In this paper, we simulated the second step of this method, which is tunnel construction. In this slide, we can see the different activities involved in tunnel construction using microtunneling, such as an example, transporting and attaching tunnel sections to the crane, lowering them into the starting shaft, jacking process, or disassembling MTBM and disconnecting cables and pipelines. In this figure, we can see the sequence and the relationships between the activities in microtunneling method, which are shown in a white box. Also, the blue circles show the resources that each activity need to be completed. Among the different activities involved in microtunneling, jacking the tunnel sections into the ground has the biggest effect on the total duration of the project. And the diameter of the tunnel, length of the tunnel sections, and geotechnical conditions of the soil can directly affect the duration of this activity. Therefore, we evaluated 2 different diameters and 3 geological conditions. In this table, we can see the other assumptions. And as I mentioned, we have 2 different tunnel diameter, 3 meter and 4 meter, and 3 different of soil type, which is fine sand, sand and gravel, and clay and mud. To assume the duration of each activity, 4 different projects introduced by Deng and Marzouk, as well as 14 projects monitored by French National Research Project microtunnels have been reviewed. And in this table, we can see the main characteristics of these projects, like type of the MTBM they use, the diameter of the tunnel, the length of the tunnel sections, and the geotechnical conditions. Because of the difference between the dimensions of the assumed tunnel and those of the tunnels in reviewed projects, the jacking duration was modified according to the diameter and length of the sections. As an example, we can see in this table that in a 3 meter diameter tunnel in fine sand, the jacking duration is about 72 minutes. And here in this table, we can see the probabilistic distribution of other activities duration. For example, the duration of connecting cables is minimum 28 minutes, maximum 48, with the mode of 36 minutes. The assumed data were fed to the DES model using ISARC software, and 100 simulation replication were made to calculate the total duration of tunnel construction. In this figure, we can see the results of the simulation for tunnel construction using microtunneling. For instance, it will take about 41 working days to build a 4 meter diameter tunnel in fine sand. Also in this slide and in the figure on top, we can see that the total duration of MUT construction, not only for tunnel construction, for all of the MUT, I mean shaft construction and placement of utilities using microtunneling. And in the figure at the bottom, we can see the results for MUT construction using cut and cover method. As an example, it takes about 75 days to build a 3 meter diameter tunnel in fine sand using microtunneling method, where for the same tunnel, if you use cut and cover method, it will take about 125 days. For the conclusions of this research, I can say that by increasing the diameter of the tunnel from 3 meter to 4 meter, the total construction will increase by 9% in microtunneling and 6% in cut and cover method. And by increasing the cohesiveness and hardness of the soil, the duration of tunnel construction will increase by 10% in microtunneling and 5% in cut and cover method. And also, the total duration of MUT construction using cut and cover method is about 62% more than using microtunneling. In future work, we will do the stochastic for the simulation of MUT construction method to consider spatiotemporal conflicts and impacts on the surrounding areas. And in this figure, we can see as an example that we can simulate the construction method, and even we can simulate the construction equipments. Thank you so much. It was my presentation, and I'm here to listen to your questions.
Right. Yeah.